guys! In the previous videos of thermochemistry, we have already covered up different aspects of thermochemistry. We learned how to represent enthalpy change. We learned how to use the formula Q is equal to mc delta T. And also we learned how system and surroundings work with respect to thermochemistry. In today's video, we will be covering up another aspect of thermochemistry, and that is calorimetry. So let's talk about the basics of calorimetry. Let's first understand what is calorimetry. Calorimetry is the technological process of measuring the heat released or absorbed during a chemical or physical process. So if we want to find out how much is the heat lost or gained during a physical or a chemical reaction, we use the process called calorimetry. And for this process, we need a device called calorimeter. So calorimeter is a device that is going to help us undergo calorimetry analysis. And how is calorimeter going to do it is, calorimeter is going to measure the heat released or absorbed during a chemical or physical process occurring within it. So calorimeter is the device in which the reaction is going to take place, and there is a way to measure the temperature changes inside the calorimeter. Let's understand how does a simple calorimeter look like. A simple calorimeter is basically made up of two stacked styrofoam cups. So if we have another styrofoam cup here, stacked on top of each other, looking something like this, filled with water inside. So we are looking at the inside of the styrofoam cup. So this is water inside it. There is a stirrer in it that helps stir the mixture, whatever we put inside this cup. Apart from the stirrer, there is a thermometer attached to this cup. So this is the thermometer. Remember, anything that is added to the cup is called the system, whereas water is going to work as surround. Let's take up an example. Let's say we add hot gold coin into the calorimeter. So this gold is going to work as the system, and when this hot gold coin is added into the calorimeter, the water that is already inside the calorimeter, also called the surroundings, temperature will go up. So let's say the initial temperature of water was at a room temperature 37 degrees Celsius. Final temperature of water is, with the gold bar in it, becomes 52 degrees Celsius. This will lead to the temperature change equal to 52 minus 37, which is 15 degrees Celsius. Because this temperature is positive, so that means the surroundings have gained heat, or we can say surroundings have gained energy. So if I want to find out Q surroundings, that will be equal to mass of surroundings multiplied by specific heat of surroundings multiplied by change in temperature of surroundings. And here we know that in a coffee cup calorimeter or a simple calorimeter, surroundings is nothing but water. So technically Q surroundings is Q of water equal to mass of water multiplied by specific heat capacity of water multiplied by delta T of water. We are given the mass of water. Let's say question has given you the mass of water is 100 grams. So we put this as 100. Specific heat capacity of water we have already learned from the previous videos is 4.19. And the change in temperature we just figured out was 15. When we put this all on the calculator, we get 6,285 joules, because Q unit is joules, of energy. Now if you want to understand how do we get this joules unit, we can just split this up with units. So this is how this work is done. It's basically 100 grams multiplied by 4.19 joules per gram degree Celsius times 15 degrees Celsius. Grams cancel with grams, degree Celsius cancels with degree Celsius. We multiply all these numbers, and the only unit that we are left with is joules. So this is the unit that comes here. So from here we got Q water is a positive 6285 joules. Now we have learned in the previous videos that law of thermodynamics states that delta E system is the negative of delta E surroundings, or we can say vice versa. In this case, water is surroundings, gold is system. So if the question wants you to find out delta H of gold, that's nothing but negative of Q surroundings. So if Q surroundings is 6285, delta H gold becomes negative 6285. joules. In simple words, we can say the amount of energy that is lost by gold is equal to the amount of energy that is gained by water. So this is how we use a simple calorimeter in order to do our calculations or to find out the energy change involved in a system of reaction. Now, in order to use this simple calorimeter, there are some assumptions that have been made, and the assumptions are as follows. First one is that the system is isolated. Now, what do you mean by isolated system? Isolated system means that if any energy is lost out of the cup, means any heat is lost from water outside the surroundings of water, that is considered to be minimum, or we can say that is considered to be negligible, so we can ignore it. Second assumption is if something is dissolved in water, be it dissolved or reacted, like in this case gold was dissolved, but there could be some reaction with water as well, then the resulting solution retains the properties of water. This is the reason we use specific heat capacity of water, and we use the temperature change of water. Third assumption is the process takes place under constant pressure. That means the pressure is not allowed to be changed in this calorimeter. There is one final assumption. We see we had 2 cups stacked.
2 cups is 0.47 liters.
We see we had 2 cups stacked, so there could be some heat loss in this in-between area, and the assumption is that if there is any heat loss in between these 2 cups, that is considered to be negligible. So these assumptions let us use our simple calorimeter. in order to do our calculations.